Hello everyone, let's look at Leetcode question 611, valid triangle number. At time of recording, this question has 3.7 thousand upvotes and 208 downvotes. The question is, given an integer array, nums, return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. Okay, so we need triplets, three sides of a triangle, and we need to determine from those three sides if it in fact satisfies the conditions of a triangle. So let's look at these examples, but first the constraints are that the array nums.length is between 1 and 1,000 triangle sides, and the values of each side will be between 0 and 1,000. Okay, let's take a look. To solve this problem, we have to consider the triangle inequality theorem that states that the sum of the length of two sides of a triangle has to be greater than the length of the third side. So let's consider every single side. So a plus b has to be greater than c, b plus c has to be greater than a, and a plus c has to be greater than b. This is what defines a triangle and makes it a valid triangle. Okay, so to solve this problem, we have the code and we're going to go through the example. So essentially what we do first is sort the triangle lengths, nums.sort, and then we iterate through every side of the triangle starting with the greatest and iterating backwards until we reach the smallest sized side of the triangle. And we define I and j to be two sides of the triangle and k to be the third side. The triangle sides at nums I plus nums j, like we said in the inequality theorem, has to be greater than the third nums k. And so then we check if this is the case, then we add the values of j minus I to the valid triangles, and then subtract j to iterate to the next side. Otherwise, we increment the sliding window, so I plus 1, if the two sides are not greater than the third side. And then we return answer. Okay, starting with this first example, we have nums 2, 2, 3, 4. It's already sorted, and we loop starting with the greatest value, so index 3, 0, 1, 2, 3, subtracting 1 each time until we arrive at index 1. So we say, okay, I is equal to 0, j is equal to k minus 1, that's 2, since it's starting at index 0, 1, 2, 3 minus 1, and we do the while loop next. I is less than j, yeah, 0 is less than 2. Now we check, is nums 0 plus nums 2 greater than nums 3? 2 plus 3 is 5, and that is greater than 4. So we say, okay, answer plus equals j minus 1, 2 minus 0, and that's 2. So answer becomes 2. And you may ask, why are we doing j minus I? Well, if you think about it, j is index 2 and I is index 0. So that means that the next value is also going to be greater than 4 because I is currently the smallest value and it's sorted. So that also means that 2 plus 3 again, that's 5, is greater than 4. Okay, and then we're doing the sliding window again, so j becomes 2 next, and I is still 2. And we say, okay, is I less than j? So j is 1 now, and I is still 0. So yes, we can do the while loop once more, and we say nums 0, 2, plus nums j, 2. Is that greater than nums k? K is still 4. And 2 plus 2 is 4, and it's not greater than 4. So we exit this if condition, and we say, okay, I plus equals 1. I becomes index 1. And then this while loop is no longer reachable because 1 is not less than 1. Okay, so then we go back up to the for loop, and then we check, okay, we decrement the value of index k, which was currently at index 3, and now it's at index 2 here, which is this value here, 3. And we say, okay, I is now equal to 0 once more, and then j is equal to k minus 1, so that is 0, 1, 2 minus 1, that's 1, because this is the index values, so it's once more, and we do the while loop next. We say, while I, 0, is less than j, this is true, we check nums 0, that's 2, nums j, that's 2 again, so 2 plus 2 is greater than nums at 2, 3. Yes, 4 is greater than 3. So then we say, okay, then we do answer plus equals j minus I. J is 1, I is 0, that's simply 1. And this makes sense because there are no values in between the first two and the next two, so we can't say that there's other values that are greater than 3. So then answer becomes 3. And then we subtract 1 from j, so j becomes 0, and we exit the while loop, and then return answer. So answer is 3 in this example. Okay, same concept, but next example. We have input nums 2, 5, 4, 3, and so we sort them. Nums.sort is 2, 3, 4, 5. Okay, so we do the same thing for k in range length minus 1 down to 1, subtracting 1 each time, so we start at index 3. I is equal to 0, j is equal to k minus 1, so 3 minus 1 is 2. Okay, and then we say, okay, while I is less than j, 0 is less than 2. This is true, so nums at 0, 2, plus nums at j, 4, is that greater than nums at k, 5? 2 plus 4 is 6. 6 is greater than 5, yes. So answer is j minus I. 0, 1, 2. 2 minus 1, or 2 minus 0, sorry. And that is 2. So answer becomes 2 now, and j becomes 1. Subtracting 1. And remember, we do j minus I because, like we said earlier, the index 2 and index 0 means that there's a greater value after the index 0, so we increment that by subtracting these two I and j's. And then it's a sliding window, so we get rid of the j value at index 2, and it becomes 3. And we check the same thing. Is I, nums I, so 2 plus 3, that's 5. Is that greater than 5? No, 5 is not greater than 5. So we exit this if condition and we say, okay, else I becomes 1. And then we do the next iteration of the while loop. So I is less than j, 1 is not less than 1. So we exit that. And then we go to the for loop once more and we say, okay, so j was currently at the last index 3. We subtract that, so it becomes index 4. And then we say I is still 0 again. And j is, what is it? So 0, 2, 2 minus 1 is 1. Okay, so then we go to the while loop and we say 0 less than 1. Nums at 0, that's 2. Plus nums at j, that's 3. 2 plus 3 is 5. 5 is not greater than 4. So we don't do anything and we exit and say, okay, I plus 1. I becomes 1, 1. And then we do the same thing. I is 1. It's not less than 1. So we exit the while loop. And then we go to the for loop once more here. And it's 3 now. And 2. So we could say eventually that the answer is 2 because there's not going to be a second j value for this k minus 1, which will mean that I is not going to be less than j. So we return 2. Okay, let's check the solution. Very nice. The time complexity is actually O(n) squared. It's O(n) squared where n is the length of the input list numbers. This is because there are two nested loops. The outer loop iterates over the elements of the nums from the last element to the third element, and the inner loop iterates from the first element to the second to last element. Therefore, the number of iterations is n squared. So the space complexity is O of 1 because it uses a constant amount of extra space to store the variables, I, j, k. That's it for this problem. Thank you for watching.